Cummins 5.9 diesel engine. In 1989, it made 400 pounds of torque from the factory, stock. Your buddy's muscle car with the big block V8, it made 350, maybe, on a good day. And that Cummins would still be making that same 400 pounds of torque at 300,000 miles when that big block was a boat anchor. If your father drove trucks in the 80s and 90s, he knows this engine. If your grandfather farmed, he definitely knows it. The 5.9 wasn't just another diesel. It was the diesel that proved everyone wrong about what diesel technology could do in America. See, for decades, diesel engines in the United States had a reputation problem. They were loud, they smoked, they were slow. They belonged in tractors and semis, not in anything a normal person would want to drive. The gasoline engine was king, and Detroit made sure everyone knew it. Big V8s, muscle cars, the American way. But there was a company in Columbus, Indiana, that had been building diesel engines since 1919, Cummins. And they had a different idea about what diesel could be. The thing is, diesel engines have a fundamental advantage over gasoline engines that most people don't understand. It's not about fuel economy, although that matters. It's about how the engine makes power. A gasoline engine needs a spark plug to ignite the fuel. That spark happens at a specific moment, and the explosion pushes the piston down. Simple enough. But a diesel engine doesn't use spark plugs at all. It compresses air so much that it gets hot enough to ignite fuel on contact. We're talking about compression ratios of 17:1 or higher. Your gasoline car runs about 10:1, maybe 11 if it's fancy. That compression is where the torque comes from. When diesel fuel hits that superheated air, it doesn't just burn, it expands violently. And that expansion pushes down on a piston that's already under enormous pressure. The result is torque. Lots of it. Low in the rev range. Right where you need it for pulling, hauling, and working. But American automakers in the 70s and 80s didn't understand diesel. Or maybe they didn't want to. General Motors tried to convert a gasoline V8 into a diesel in 1978. The Oldsmobile 5.7-liter diesel. It was, by most accounts, a disaster. The engine wasn't designed for the pressures diesel combustion creates. Head bolts stretched, gaskets failed. The engines ate themselves alive, sometimes before reaching 50,000 miles. GM sold these engines in Cadillacs, Oldsmobiles, and even some Chevrolet trucks. And when they failed, which they did constantly, it poisoned the entire American market against diesel passenger vehicles for a generation. People who bought those cars swore they'd never buy another diesel, and they meant it. So when Chrysler announced in 1989 that they were putting a diesel engine in their full-size pickup trucks, a lot of people thought they'd lost their minds. Hadn't GM already proven that diesel didn't work in American vehicles? But Chrysler did something smart, something that seems obvious in retrospect, but was actually pretty unusual at the time. They didn't try to build their own diesel engine. They went to the people who actually knew how to build diesels. They went to Cummins. Cummins had been building heavy-duty diesel engines for decades. Engines for 18-wheelers, engines for construction equipment, engines for marine applications. These weren't converted gasoline designs. These were purpose-built diesel engines designed from the ground up to handle the pressures and stresses that diesel combustion creates. The engine they developed for Chrysler was called the B-Series, specifically the 5.9-liter inline-six. And right from the start, it was different from anything else in a pickup truck. First, the configuration, inline-six. Not a V8. This matters more than most people realize. An inline-six is inherently balanced. The firing impulses naturally cancel out vibrations in a way that V8s and V6s can't match without balanced shafts or other complications. The result is an engine that runs smooth. Really smooth. Diesel smooth wasn't supposed to be a thing, but the Cummins 5.9 made it one. Second, the construction. The engine block was cast iron, heavy, yes, but strong. The kind of strong you need when you're compressing air to 17.5 to 1 and then hitting it with burning diesel fuel several thousand times per minute. The rotating assembly was built like industrial equipment because that's exactly what Cummins was used to building. Third, the displacement. 5.9 liters from 6 cylinders. That's just under 1 liter per cylinder. For context, most modern passenger car engines have cylinders around half a liter each. The big cylinders in the Cummins meant big pistons, big connecting rods, and big bearing surfaces. More surface area means lower stress per square inch. Lower stress means longer life. The first generation 5.9, introduced in 1989, used a mechanical injection system made by Bosch. The VE rotary injection pump, no computers, no electronics, just precisely machined mechanical components delivering fuel at exactly the right moment. That mechanical simplicity was a huge part of what made these engines so reliable. There was nothing to go wrong electronically because there was nothing electronic. The injection pump was driven directly off the engine's camshaft. Timing was set mechanically. Fuel delivery was controlled by mechanical governors and linkages. Could you tune it? Absolutely. Turn a screw here, adjust a linkage there, and you could add 50, 75, even 100 horsepower. Guys figured this out pretty quickly. The trucking forums in the 90s were full of modification guides. Cummins had built so much margin into the engine that it could handle a lot more power than it made from the factory. From the factory, the 12-valve 5.9 made 160 horsepower and 400 pound-feet of torque. Those numbers sound modest by today's standards. But here's the thing about torque in a diesel. It's available right now. Not at 5,000 RPM, not at redline. Right now, at 1,500 RPM, when you're pulling a trailer up a grade and you need the engine to actually work. The gasoline engines in competing trucks made more horsepower on paper. The Ford 360 V8 made 210 horsepower, but it made its peak torque at 2,800 RPM. The Chevy 354 made 230 horsepower, but again, peak torque was way up in the rev range. The Cummins made peak torque at 1,600 RPM. It felt like the engine was loafing when it was actually working hard. And that's exactly what you want in a work truck. If you're enjoying this, hit subscribe. We cover stuff like this every week. Okay, back to it. Chrysler paired the Cummins with the Getrag 360 manual transmission initially, and later with automatic options. The manual trucks became legendary for their durability. Some of those original 1989 and 1990 trucks are still running today. Not restored, not rebuilt, just running. 300,000, 400,000, 500,000 miles. There's a reason Cummins trucks from this era command premium prices on the used market. A 93 Dodge with the 5.9 that's been maintained will sell for more than a comparable Ford or Chevy from the same year with a gasoline engine, sometimes significantly more. The engine just lasts. Now, the 12-valve engine ran from 89 through 98, 10 years. During that time, Cummins made incremental improvements. They added an intercooler in 91, which dropped intake air temperatures and allowed for slightly more power without additional stress. They refined the turbocharger. They improved the fuel system. But the fundamental architecture stayed the same. Cast iron block, forged steel crankshaft, forged connecting rods. The kind of parts you'd expect in an engine designed to run for 1,000,000 miles in a commercial truck, because that's exactly what Cummins designed them for. They just happened to put it in a pickup. The competition didn't know what to do. Ford had their 7.3-liter International diesel, which was a good engine, strong, but it was a V8, and it didn't have the same smoothness or the same low-end torque character as the inline-six Cummins. Chevy had the 6.2 and later 6.5-liter Detroit diesel engines, which were fine. They worked. But they never developed the same reputation for bulletproof reliability. Cummins had something else working in their favor too: parts availability. Because the B-Series engine was used in so many commercial applications, not just Dodge trucks, but buses, agricultural equipment, marine applications, industrial generators, you could find parts anywhere. And those parts were designed for commercial service life, which meant they were overbuilt for pickup truck duty. A fuel injection pump for the Cummins might cost more than one for a gasoline engine, but it would last 200,000 miles. And when it did need rebuilding, any diesel shop in the country knew how to work on it. Try finding someone who can rebuild a finicky electronic fuel injection system on a 20-year-old truck. Good luck. But a mechanical Bosch pump? Every diesel mechanic in America has done that job. In 1998, Cummins introduced the second generation, 5.9, same displacement, same basic architecture, but now with electronic fuel injection. The VP44 injection pump from Bosch replaced the mechanical VE pump. This was a significant change. The electronic injection allowed for much more precise fuel delivery, better emissions, better cold starting, a more refined driving experience. Power went up too. The 24-valve version of the 5.9 eventually made 325 horsepower and 610 pound-feet of torque. 610 pound-feet. From a pickup truck engine, the big block V8s that dominated muscle car mythology made 300, maybe 350, on a good day. And they did it at higher RPM, with worse fuel economy and nowhere near the longevity. But the electronic injection also introduced new failure modes. The VP44 pump developed a reputation for failures, particularly in high-mileage trucks. When it failed, it often sent metal debris into the fuel system. An expensive repair. The purists preferred the earlier mechanical trucks for this reason: simpler, fewer things to go wrong. Then, in 2003, Cummins introduced common rail injection to the 5.9. The CR system used incredibly high fuel pressure, over 23,000 psi, to atomize fuel more completely. Better combustion, better power, better emissions. The common rail 5.9 could make 325 horsepower and 650 pound-feet of torque while meeting tightening emission standards. But with that complexity came more potential failure points. Injectors operating at 23,000 psi are precision instruments. They don't tolerate contaminated fuel. They don't tolerate water in the fuel. They don't tolerate neglect. The earlier mechanical engines would run on practically anything that burned. The common rail engines needed clean fuel and careful maintenance. Still, even the later electronically controlled 5.9 engines were overbuilt compared to their competition. The basic architecture, that cast iron block, those forged internals, that inline-six configuration, remained fundamentally unchanged. Cummins knew how to build an engine that lasted. The 5.9 also found its way into applications beyond pickup trucks. School buses across America ran the B-Series Cummins, commercial delivery trucks, agricultural equipment, marine vessels. When you needed an engine that would start every day, work hard, and not complain, you bought a Cummins. There's a reason for that consistency. Cummins designed these engines with a concept called headroom. They never ran their engines at the edge of their capability. The 5.9, making 400 pound-feet of torque from the factory, was probably capable of making 600 reliably, and 700 with some stress. The factory rating left enormous margin for durability. Compare that to a modern turbocharged gasoline engine, making 250 horsepower from 2 liters. Those engines are optimized. Every component is engineered to the minimum necessary specification. They're remarkable achievements of efficiency, but they don't have headroom. They're running at their limit from the factory. The Cummins approach was different. Over-engineer everything. Use components rated for more stress than they'll ever see in service. Accept the weight penalty and the cost. The result was engines that refused to die. The 5.9 was replaced by the 6.7 in 2007 for the Dodge application. More displacement, more power, better emissions compliance. But many enthusiasts consider the 5.9, particularly the earlier mechanical versions, to be the sweet spot. Complex enough to make good power, simple enough to be virtually unkillable. So what's the legacy of the 5.9? It proved that diesel could work in American light trucks, really work. Not the half-hearted attempts from GM that poisoned the well for a decade. Actual, functional, desirable diesel technology that people wanted to buy. It proved that torque matters more than horsepower for real work. The marketing departments could argue about peak horsepower numbers all day, but the guys actually using these trucks to pull trailers and haul equipment knew what they needed. They needed torque, low-end torquey. And the 5.9 delivered it better than anything else on the market. It created a market for diesel pickup trucks that didn't exist before. Before the Cummins Dodge, diesel pickups were rare, specialty vehicles. After it, they became a significant market segment. Ford improved their diesel offerings. GM improved theirs. Competition made everyone better. But Cummins started it, and it built a reputation for Dodge trucks that persists to this day. The Ram heavy-duty trucks are still sold with Cummins diesel engines. It's been over 35 years of that partnership. The 5.9 and its successor, the 6.7, have become synonymous with the Ram brand. People don't buy a Ram 2500, they buy a Cummins. That's not brand loyalty you can manufacture with marketing. That's brand loyalty earned over decades of engines that simply worked. That started when they were supposed to start. That pulled what they were supposed to pull. That were still pulling at 300,000 miles when any gasoline engine would have been rebuilt twice. Walk into any diesel mechanic's shop today and ask about the 5.9. They'll have stories. The truck that came in with 400,000 miles for its first injector service. The farmer who ran the same engine for 20 years in a tractor, then pulled it and put it in a truck. The guy who converted an old 5.9 to run on waste vegetable oil and drove it for another 100,000 miles. These engines became folk heroes in a way that gasoline engines rarely do. The small block Chevy has its devotees. The Ford Flathead has its place in history. But the Cummins 5.9 has something those engines don't, a reputation for being essentially unkillable in stock form. You can still buy them. They're out there in trucks from the late 80s through the mid-2000s. The prices are climbing as people realize what they have. A clean 12-valve truck from the early 90s might sell for $20,000 or more if it's in good condition. That's for a 30-year-old pickup truck. The market is telling you something when it does that. It's saying these engines are worth more than their replacement cost. They're worth more than a comparable new truck in some ways because you can't buy what they offer anymore. Simple, mechanical, overbuilt, durable. The modern diesel engines are better in almost every measurable way. More power, better emissions, better fuel economy, more refined, but they're also more complex, more dependent on electronics, more difficult to service, more expensive to repair when something goes wrong. The 5.9 exists in a sweet spot that doesn't exist anymore. Powerful enough to do serious work. Simple enough that a competent mechanic with basic tools can keep it running forever. Built with enough margin that it doesn't really wear out under normal use. Cummins outsmarted the gasoline establishment not by competing on their terms. They didn't try to make a diesel that revved like a gasoline engine or sounded like a gasoline engine. They built a diesel that did diesel things better than anyone else. Torque, durability, efficiency, the things that actually matter when you're trying to get work done. The 5.9 proved that diesel wasn't a compromise. It was an advantage, the right tool for the job. And once people figured that out, they never went back. So that's the Cummins 5.9, an engine that was supposed to be too heavy, too slow, too expensive, an engine that the gasoline establishment said American truck buyers would never accept, an engine that's still running strong in trucks with 500,000 miles on the odometer while those gasoline competitors are long gone. Sometimes the market gets it right. Sometimes the best product wins. The 5.9 was one of those times. Let me know what you think in the comments. If you've got a 5.9 story, and I know some of you do, I want to hear it. Subscribe if you want more like this. We do deep dives on engines, vehicles, and engineering every week. See you in the next one.